So what is virtualization and how does it apply to utilities? So virtualization is basically the ability to uncouple from the hardware applications and services. So we can create applications and services that can be used independent of the hardware vendor that you're running on. The IT industry has adopted virtualization, and cloud vendors have adopted virtualization, and with energy transition, asking utilities to consider adopting virtualization can benefit them. So let's discuss why that is important to utilities. When you see the renewable resources being adopted in the grid and you see the electric vehicle transition that's happening, in addition to all of those, there's a digital transition that's happening in the industry, and that promotes a lot of change. And that means that the systems we use to monitor and manage the controls in the grid also need to evolve to support those. We think that going forward, that transition will be based on some standards like IEC 61850. IEC 61850 involves some additional things like technologies like IP and Ethernet that are brought in. They also involve time synchronization end-to-end. You can simplify the updates and maintenance. You can have all of the protection and control software now running on a single platform, and that creates efficiencies, cost efficiencies, and upgrade and maintenance efficiencies for utilities. So an additional benefit of virtualization is the fact that the physical size of the substation gets reduced. With all of the physical individual purpose-built equipment in the substation, you reduce it from either dozens or hundreds of devices down to just the servers that are necessary to run the load that needs to be deployed to manage the grid. Yeah, so let's look at the examples of implementing virtual protection. Basically, one of the things that Nokia is doing in the background, we have an example that we built with some partners, members of the vPAC Alliance, that we have substation to substation communication using the virtualized architecture that we were talking about. And the second thing is we've seen utilities evangelizing how to move to a successful virtualization. We've seen utilities like Southern Cal Edison and Salt River Project that are also part of the vPAC Alliance demonstrate, how do I successfully migrate and evolve my substation architectures to be able to do virtualization on a standardized platform like 61850. As we go forward, it's probably important to discuss how utilities can evolve to embrace these new virtualized architectures in the grid. And we see some fairly obvious steps. Some of them are very easy. Things like promote learning among your operational staff, your protection and control staff, make sure that they share that knowledge, socialize it so that everybody understands what the risks and mitigations are of moving to a virtualized architecture. The second thing is prepare your communications networks, prepare your data centers for the migration. The migration is going to involve moving from those physical assets that we talked about earlier to virtualized assets. So there will be changes to time synchronization end-to-end that we discussed. There'll be changes to bandwidth consumption. There'll be changes to power requirements for the equipment that are in the substation. The third thing to look at is when we look at the partners that we've built here in this substation to substation, look at some of the established vendors that are already working with utilities to be able to do virtualized IEC 61850 type architectures. They're the ones that are working the hardest on developing the best practices that we're going to need moving forward. And when we talk about best practices, I think the fourth thing to consider is the simulation tools that are available and the testing that needs to be done in order to prove out before you put things into production. So, for example, being able to test without actually having physical copper wiring running everywhere, without having merging units, physical merging units that are there, you can simulate those in a software environment, which means testing can be done faster, more efficiently, without as much time for setup, teardown, and reconfigurations. Design can be done faster because you're doing it on standardized platforms. You're allowing for some well-adopted industry best practices in doing the design. It's software. The software is on platforms that are pretty well understood from web scalers, from carriers, from large data center operators. So that means that you can do maintenance and upgrades a little bit quicker or more in a more structured way. And that means that being able to simulate the resiliency and also the safety of the grid will become things that can be automated. And the automation is what's going to drive a lot of the efficiencies that we're going to see going forward with virtualized type architectures. One of the points of virtualization is that you can bring in other partners as needed. In fact, it's required. Those collaborations become vitally important. For building this substation to substation demo and even some of the things that the utilities have already presented, they make a point of talking about how the collaborations with their partners have driven the success of being able to do the implementations. In this particular case, we worked with Intel and ABB and Dell. They're all part of the vPAC Alliance that we mentioned earlier. We also had additional collaborations for success, and that was with companies like Megger and Albedo.